Hello and welcome to your 10th Java programming tutorial. I am Evan. In this tutorial, I will go over some things that I have not taught you before, like in the previous lessons, and those are switch, trigonometry methods, exponential methods, rounding and casting, and the character primitive types, as well as how to do substring and index of. And I will finish off to convert string into int and doubles. But before even we start the lesson, let's go over the previous homework that I left last time. So the first homework look like this. So I will go through them one by one. Expand this. So we have a scanner and also a random. Those two are imported by the Java util. And then after that, I will have the main method. And inside the main method, I will having a bunch of executable methods. So inside the I will close those and close the main method. And let's go over the random array first. Let's close the other ones. So random array, you will get my rows and columns by the user input, and it will create a new array with empty arrays and then populate it with the random number that is going to create. That's the random object, and it will be from 0 to 9 because its upper bound is 10, and then it will be having two loops, first the row and second the column. So row what, column what, and then it will give me the desired random number and then assign it to the index of the array. And after that, after it finished generating, now let's go on to my second method, check conditions. So if user's input is greater than 1, then do nothing. If it's less than 1, if it's 0 or negative number, so please enter a positive dimension. So this one's one of my homework for my college, so I'm trying to be as clever as possible and be as secure as possible to not break the program. So in here I print out please enter a positive dimension, and then I quit the program. So this is a good way to check. So get user input, that's still the user input for the rows and columns, and then just check it. If it's less than 1, it will be print out a error message. So after that, I will have to print my array out. So for double loop, two loops, nested loops, or whatever you call it. So first the row and second the column, and then print the row and the column plus a space, and then print out my next one. So this one is only printing. So after I finish one of the columns, so first row, all the columns, print out a line feed, and then print out my second row and third row, and so forth, so on and so forth. So that's the print array. And after that, just print sum and average of the total. So that one will be easy. You have a sum that's initialized before anything, and also initialize a counter, and then a double loop or nested loop. You will have a sum be assigned to the array value, and then assigned to my sum, and then a new array value, and then add it to my original sum. So this one will be 0, and then plus another number, plus another number, plus another number, and then you will have a counter also. So after this one loop through, it will give me a total of how many numbers you have. So I have the sum divided by the counter to get my average. So average is the total number divided by how many numbers you have. So that's done, and then I will print out the sum of all the number is this, and then the average of the number, it will be the average. It will be the sum divided by the counter. Now let's take care of this one. Let's go on to the next one. So this one is find the average and the sum of the rows. So for each of the rows, you have to initialize a new sum and then a new counter. So for each of the column, you will have the sum be equal to 0, and then you add each column. So first row, add all the columns, and then add the counter, and then average it out, and then print it out. And after that, go on to a new loop, create a new sum equal to 0, and then a new counter equal to 0, and then print out my row 0, row 1, row 2, row 3, each and individual ones. Because this one, the system out of print, is inside my for loop. So do you see this? This curly braces for the outer loop, and then this print out statement is inside my outer loop. So this one will get printed every time each row is going to execute it once. Then now this one is the sum and average of the rows. So let me go over one more time. So get my zeros, my rows. If I go to row 0, get my sum for each and every column of the row 0, and then get my counter, do my average, and then print it out. Do it the same for each and every individual rows. So that's it for the sum and average of the rows. Now let's get a bit more interesting for the sum and average for the columns. So this one, you'll get my column first. So for each column, my sum is 0, and then my counter is also 0, and you have the rows. So for each column, print out the sum of the rows, so each vertical rows, and then you add the sum, and then add the counter. You divide the sum by the counter to get the average and print it out, and then that's the first column done. Go on to the second column and then print it out each and every individual ones, and then print it out, and then the third, each individual rows, the row 0, column 1, row 1, column 1, row 2, column 1, so you're going vertically down. And then you'll print out the average and also the sum. So that's it for the sum and average of the columns. Let's close this and then print the average of the major and minor. So for the print sum and average of the major, you will have the sum, which is only going to be one sum and one counter, because there's only going to be one output. And inside there, for the length of your how many rows you have, you get I plus 1 is less than or equal to array at 0.length. So I will show you this in Photoshop. So this might be a bit confusing. So first, you have all your rows and all your columns. So when you get you have to be a square matrix, right? So since you have a square matrix, and then your length, your array length is 1, 2, 3, 4, 5, 6. So you have a 6 index from 0 to 5. So in here, you have I plus 1 is less than or equal to array.length. Array at 0.length, that will be the same thing, because your array at 0.length is 0, 1, 2, 3. Missing a column. I'm so bad at this. 6 by 6, and then you have your I plus 1 is less than or equal to 6. So your I is 0, 0 plus 1, 1 is less than 6. And that will be printed. Your index array at row I and column I will be on this one. And then next one, it checks this statement, it will be on this one. Because your I equal to 0, I equal to 1, I equal to 0, I equal to 1, so 1, 1, 2, 2, this one, 3, 3, 4, 4, 5, 5. So this is a way to do it for the majors. So after it reaches 5, so 0, 1, 2, 3, 4, 5, and then inside here is 5 plus 1, so this becomes 6. So it's 6 less than or equal to 6. Length, that would be 6. Your length should be 6, and then index should be 0 to 5. So I plus 1. So is 6 less than or equal to 6? Yes. And it will print out my last one. It will end the loop. It will not there will not be next one, because 5 it will be your upper bound. The 6 will be your upper bound. So I less than 6, so the 5 will be my last digit. So if I plus 1 is less than or equal to 6, then add a sum and then add the counter, and then it will end up displaying the counter. And then the same thing for the next one. Delete the comment. So first you have to initialize both the sum and the counter, and inside here you will have the I equal to 0, I less than the length of my rows, and then inside there it will be the same mechanism. I plus 1 is less than or equal to my length, so this is 6, so it will be less than 6. And then inside there, sum is plus equal to I, and then my column will be I at length minus I minus 1. So think of it this way. So first you have your array dot length, and then after that length, this one it will not be recognized because your length should be 1 greater than your index, right? So length minus 1, that's your last index, right? And then minus I, if I row 0, it will be this one. If I might row 1, so length minus 1 minus another 1, because my I is my rows, it will be this one. And then the next one, length minus 1 minus 2, because I'm on row 2, and it will be this one. It will be going down like this to give you a minor. And then so this is how you do a major and minor. So think of it clearly, you will get the same result. Mine, it does not have to be less than or equal to this number. It can be I less than or equal to something minus 1. It will be the same thing. Just do the normal equality operations. You can subtract 1 from both sides and you can do whatever you want with it. So math majors or computer science majors, you have to be very clever with your conditions. So that's it for the first one. Let me go over the main method for this problem. So inside my main method, I have get my scanner. So how many rows to print and then how many columns to print. And inside here, I'm going to create my new array with a random array. So that's how this come in. This one, I create a new array and I return that array. So this array is going to be the array that I'm assigning to this new variable called int array equals to random array. So this array is the one that we're going to use repeatedly. So if I return this into this, and then if I do not have this, then I'm going to use this over and over, which is not what you want, because every time you call this method, it's going to generate a new array. I want to assign it to a variable so I can use that definite random variable over and over again without creating a new random array every time. So this one, I assign this specific value to this variable, and I'm going to use that variable over and over again. So print the array. It might not be a square matrix, it can be a square matrix. So inside there, get a sum, get my rows, and get my columns. Those are not a problem. So I use the example of a square matrix, but if you're not having a square matrix, if you're having one list, let me make the eraser bigger. If I have one list columns, then it will starting from here, and then goes all the way down. So it will be the same mechanism, and until the last row, if it's not going to reach, because if this one, if I plus 1 is less than or equal to this one, and then when you're going down, you're getting your row dot length. You are getting this, and then when it reaches here, it's not going to be printed out in the last one. This will not be printed out, and you will end up with only 5 values. Add them and then get the average. So that will be the same for this. If I have my I equals 0, I minus my length, and if my I plus 1 is less than or equal to my length, we're going to do the first one, second one, third one, fourth one, and fifth one. You are not going to be on the sixth one because it's going to be out of bound. Here, I have missing a column, but the program will just stop here because I'm getting my array at 0.length. Array at 0.length, in here only have 5, so it's only going to print 5 values. And then when you try to reach 6 in here, and then it's 6 is not less than or equal to 5, so it's going to be cancel this one, and then it's not going to do anything. So it's going to print 5 values, add them together, and print out my sum. So I cannot stress this enough. I'm going to do it one more time. So blame me for repeat it over and over again. But I need you to get this. If you do not have a perfect matrix, you have a 5 by 4, then you will print out my first one, second one, third one, fourth one, and since my array at index 0.length will be this, which is 4. So if it reaches on row number 5, so 5 is not less than 4, it will not be printing on the last one. It will only be printing on the 4 that's existing and only fits the condition that you have. So it only will fit this condition and it will add the sum, otherwise it's not going to do anything. So this one is that. You have to know this because it's going to be very important when you doing the real life applications and those stuff. So you have to do the major and minors, and those are very important. So let's close this. Now let's go on to my second problem. And I'm going to close this. So in here you also have a scanner and random, those two utilities from Java. Inside here I'm going to close my main method, close all the methods. So you have to do check conditions first. So let's check conditions. If user input is greater than 1, then it will be print out nothing. So in here, do nothing. And else, it will print out, please enter a positive matrix dimension, and then it will create out the program. So this is a way to check if your users input the correct dimension or not. So that's it. That's that for random generate. You have to generate a new random object, and for I equals 0, I less than array.length, that's your rows, and then your columns. Random generated if it's 1 or 2, if it's 0 or 1, because upper bound is 2, it will generate between 0 and 1, and then you are going to assign that value to your whatever row and column it is, and return that array. So after you return that array, you have to print it out. So this is the new one that you have to remember. It's not going to be very important, but it's very easy and it's going to help you a lot. So in here I'm going to print line. So print out a line first. It's going to make the output a little bit more clean. And then for the double loop, so you already know this. So without using the if, so if I equal to 0, print out this. If I equal to 1, print out another one. I will able to print this one. So array at index I and column j, is it equal to 1? Equal to 1? So double equal. So is it equal to 1? Question mark. Is it? So if it is, print out x. If it's not, then print out O. So this is called a ternary, to do an output based on a if and else statement. So this will only have 2 options. There's not going to be 3 options. So it's only going to be true. So the first value is going to be true, and then the second value is going to be false. And so if it's equal to 1, print out x. So if it's not 1, then it must be 0. So 0, I'm assigning O to it. So it's going to be print out an x or an O. And then print out a line for each column, and then print out a new row. And then print out for each row, it's going to print out a new line feed. So inside here, notice I'm using print, so I'm having a symbol and then a space after that, because it's going to be separated between each symbol and it's going to be making more clear to see. So after that, you're going to have a line feed for each row. After the first row, print out a line feed. After the second row, print out a line feed. And after that, it's going to be ending the nested loop and then print out another line, display it more clear. So after that, let's close this and print out this one. So check for rows. So for the rows, I equal to 0, I less than array.length. It's going to be ordinary things. So inside here, I have 2 variables, one called initial symbol and other one called dummy. And then the dummy is going to check every time if it's the next, for the next column, if it's identical to the previous column. So if they're the same, then proceed to the next column. And if you reach the last column, so let's go over the loops first. So for my dummy, it will be my I that's my rows. So if I have I equal to 0, so row 0, column 0, so that's my initial value, and then that will be setting to my dummy. And then my initial symbol, that will be a 1 or a 0. So for int j equal to 1, and then j is less than array type I.length, so this one should be my column. So array at I dot length shall be how many columns there are in my first row, so in my I row. So if dummy is equal to array at I and j, so because I already have I 0, then j should be starting at 1, so it will be my row 0 and my second element or index at 1. So if they're equal, then dummy should be equal to my new value. So if this one, let me show you in here. So I have my dummy equal to this value. So if my next value is the same as my previous value, then my dummy should be equal to this value also. And then when my dummy is at here and it's going to check my next value again, if this value is the same as my previous value, then dummy is equal to this. And when my j, that's my column, so when my j plus 1 is equal, double equal sign, to my array, if my j plus 1 is equal to my array at I dot length, so when you reach the last value, so if they're all the circles, they're all the same, then print it out. All in my initial symbol, so what symbol is this? If it's 1, then it should be X. So if it's 0, then it should be O's, and then print out what row they have. So this is a good way to do this. So if the first one and then my next one, so my dummy is equal to 1, my j is equal to 1, and this one is the same as my previous one, so my dummy is equal to this value. And if my next one is X, then you will check if this one is false. If dummy is equal to my array at I dot j, if my j equal to 3 and is an X, then it will not be passing this condition, the if condition, right? So if this if statement is false, then you will break the loop. So if it's false for this one, then you will break the entire loop. It's going to start on a new row and check every column. So this is a mechanic that you have to learn. So if this one is not equal to my next one, go to a new row to check if this first one is circle, second one is circle, third one is circle. So that's that. You have to get your initial value because you are checking for all the column within one row. You have to get your first value in your row and then check for your next column. And then it will be the same but a different way to loop for your check for the columns. So you get a array at 0 dot length and then I plus plus. And you have also your initial symbol and also your dummy symbol. This one is going to loop for getting your columns and then do your rows for this one. So you get your first column, so index at 0, 0, and it's going to loop downward. So if this one is, you go to the previous one, your dummy goes into here. And if this one is X, your dummy checks for this one, and then it's not equal, then it will directly jump to column number 1. And then it will going to check again and again. If it's pass, then it's going to print out whatever it is, whatever column, whatever rows it is. It's going to be all symbols X or O's. So this one should be I plus 1 because you are starting from index 0. You should be plus 1 to get the user to know which column it is. So as I said, if this one is not the same as the next one, it's going to be break out from the loop. Now if this is done, let's check major and minor. This one's pretty easy. You have two symbols, both at 0, 0, and for int 0, and then I equals less than, and I is less than your array dot length, so I plus plus. If this the dummy, so I is this one, and then when I equal to 2, it's going to be this one, I, so 0, 0, 1, 1, 2, 2. Next one should be this one, 3, 3. Because this one is a square matrix, you only enter one value, it's going to be a square matrix, so this one does not count. So 3, 3. So this one is only going to matter like this. So if those are all the same as a as the same. So if my dummy is equal to my array.ii, so this one is equal to this one, then my dummy should be assigned to here. So if my dummy at this value is going to be the same as my length value, then my dummy is going to be here again. And then my dummy is in check for its next value. So if the dummy and the last value is going to be equal, then my dummy should be in here. And when dummy is at the last position, so if I plus 1 is equal to array.length, so array.length is going to be your 0, 1, 2, 3. So array.length should be 4. So I can only go up to 3. So I plus 1 should be 4. So if 4 equal to 4, then I'm going to print out my major diagonals is going to be all X or all O's. And then the same for chicken minors. It's going to having the initial symbol at J. J is going to be 0, and array.length minus 1. 1, 2, 3. 1, 2, 3. So your first value should be at row 0, your last column, array.length minus 1, that's your last one. So my dummy value is like here. So if this value is equal to itself, then it must be equal to itself. And then it will pass my if statement, and my I should be plus plus. So now my row is equal to 1. And then also my I is going to be decreased by 1. So this one, the I should be length minus 1. And then next one is going to be length minus 2. And then length minus 3, length minus 4. And then it's going to be going downhill like this one. So it's going to check all your minors. Like this one, your length minus 1. And then your I is minus minus. So if this one is end up at 0, 1, 2, 3. So if length is 4, then you will be 4, 3, 2, 1 as long as I is greater than or equal to 0. So at 0, so this column and then this row, whatever the row is going to be checking for the dummy one last time if it's equal. And then when the I is equal to 0, then it's going to print out if this one is equal to that, if that one is equal to that. And then when the dummy is not equal to my next value, it's going to be break out from the loop directly. So after those explanations, let's go on to my main method. Inside my main method, I'm going to create a new scanner. The user input to the matrix size. This should be a square matrix, so it does not have to require both the row and the column. And then after that, check my condition if the user input is a positive or a negative number. And then user input to create a new array to have the user input, so you will give me a square matrix as well. And then generate an array to fill it up with all the numbers that you required, ranging from 0 to 1. So it's going to be X or O's, and then it's going to be printed out. So it's going to print out the 2D array, and then check for rows, columns, major, and minor. And then that's it. Let us run this, or save this and run it into the matrix size. Let's go with 5. It's going to be 5 by 5. And then all X on the minor, so X, 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 X. So that is how you do it. And if you don't understand, just look back at my homework answer code and try to understand it. So I explain as the best as I could. So just get the algorithms into your head. It's going to be very progressive. If you figure out the first 1 or 2 rows, it's going to be extremely easy for the rest of them. And then just set up your boundary correctly and you will not have any problems. And that's my second problem. Let's go through my first problem as well. So let me go open my first problem. Wow, my notepad has never taken this long to open. Holy. So open browser. Now let's run this. Enter the rows 5 by 3. So you will have this, and then you will have a collection of all the data you're going to have. So row 0, row 1, row 2, row 5. So row 0, I'm having a mistake. I should put I plus 1 for this. So yeah, so this one I'm making a mistake, so it should be row 1, row 2, all the way up to row 5. So if you want to make it perfect, then don't use my code. Now today I'm going to show you something that I have not taught you before. It's going to be pretty, not hard, but something that I wanted to teach you but end up forgetting it. You don't even need to import anything. So in here, I'm first going to teach you how to use a switch. So switch is a statement that you can check to have a single output or only one possibility output. So if I have my int a equal to 5 and I have a switch, so in this case what we usually do is to use if statements for each individual possible outcome, but there is a different way and then it's a much faster way. So switch parentheses, inside the parentheses put in your condition that you want to check. So it can be any primitive type, so not double, so it can be a also not float, so it can be a int, byte, long, and it can also be a string if you have the same string. So switch a, and then inside my curly braces I'm going to be putting all the cases in here. So case 1, so if my a is equal to 1, then put a colon and curly braces. And what's going to be in there is going to be what's going to be executed. So system out of print line. This is going to print out plus a. So for case 1, I'm going to copy this. 2, 3, 4. Case 2, case 3, case 4, and I'm going to have a case 5. And I'm also going to print out another statement. This is a switch statement. Now let's save this and run it. So this is going to print out 5, and this is a switch statement. And it's not going to have any problems. However, if I change this to 1, look at what's going to happen. So this is going to print out 1, this is going to print out 1, this is going to print out 1. Do you see a problem here? So this is going to be printing this one, but it's not going to stop. It's going to be print out this one, this one, this one, and also this one. So how do you stop this? So here's a trick to have break every time when you want to use a switch statement. It's going to be executing this code, and it's going to be breaking out from this switch loop, and it's going to be ending up in here. So after whatever you have here, this is the end of the switch statement. Save this and run it. So it's going to be printing out 1, and it's going to break, and it's going to print out what's after the switch loop. So give break for each and individual one of those. That way you are not going to mess up your code. And what if none of them matches? So if I have 6, it's not going to be matched up with any of those. So what if you want a default statement to print out something that's at least something useful? So use the keyword default, have a curly braces and a colon inside there. Let's go system out. This number is not within the switch, but the number is plus a. So print it out. So this number is not within the switch, but the number is 6. So case, it can be any case you have. However, it might not be inside your case. So if it's not inside your case, you can have a default to always print out something if it's not within any of your cases. So if I have 1 again, it's not going to be print out the default statement, because default is only going to print if none of the cases matches. So this is how you do a switch, and it's going to be saving you a lot of time when doing your programming on your final exam. So I'm going to be planning out the final exam. Looking forward to my next video for that. And then after the switch, I'm going to teach you how to use trigonometry methods. So those are things that I don't think is going to be matter when you're trying to learn algorithms, but more on the calculation part. So math, the sine, okay, you can have sine, sen h, arc sine, and all those stuff, and then it will be the same as cosine, cosine h, and arc cosine, same thing. So just trying to show you. Going to system out this one. So let me test you. What if sine of pi, messed up pi, divided by 2, missing a parentheses? So, ready? What is it? It's going to be 1.0. So, you know that when you have two math operations, it's going to be matter by the parentheses. Which parentheses comes in last is going to be execute first. So like your ordinary math operations, it's going to be goes this one first, and then do the sign of this, and it's going to print it out. So it's going to be inside out, do the inner ones first, and then outer layer, and then the most outer layer, and it's going to be executing the main. So that is done. So trig, sine, cosine, tangent, arctan, arccotan, and those stuff is all going to be work the same way as you think it is. So math, whatever you have. So that is that. Let's go on to the exponential problems. So here are some exponential that you can do. So if I have exp, so when I have math.exp, so this should be a return a e raised to the power of x. So if my power is exp to my second power, so this one should be a double. So if int is going to be cast to a double. I'll explain casting later. So system out this. And then try to run this. It's going to be 7.3438 something. So you know the small letter e, and then you raise it to the square. So this is exactly the same as this. So math.e raised to the power of x. So your 2 is your x. So e raised to your x. Your x can be anything. So if you have that requirement, then that's what you type. And then also log. So let me specify this. So math.log, this is natural log. So this is the same. So I'm just trying to make you understand. So math.log, this means the ln of something. And then when you have math.log10, this is your log10 base. This is your ordinary log. So log base 10. So this in the computer science, you have to use math.log10 to get your log base 10. So if you have any other logs, you have to do the conversion. So you have log base 8, you have to do the standard formula to get your log base into 10, and then have some weird expression. I totally forgot how that works. And now the power, math.power, you already know this. Math.power, your base and your power. So 4 to the second power, 16. So that's not going to be a problem. And also the one last one, math.square root of a double. So I have a 9, it's going to give me 3. So someone might ask, what if I want to get my cube root of something? So your algebra teacher, make them proud. Math.power of my 27 of my 1/3. That's going to give me the cube root of something. Trust me, it works. Now let's try this. So if I want to print this out, going to give me. Now after we're done with the exponential methods, now let's go on to rounding and casting. So for rounding, there are a lot of roundings. You can have math.ceil, that will make it to the next whole number, so your highest whole number. So you get 1.1 is going to be sealing to 2. So if math.ceil of 1.9 is also going to give you 2. So if you need that requirement, that's how you do it. So math.ceil, and then also math.floor. So you probably know what this is. So 1.1 is going to be give you 1. Then math.floor of 1.9 is also going to give you 1. So for negatives, it's also going to give you the same thing. If you have math.ceil negative 2.1, it's going to give you negative 2.0, because it's going to rounding up like in the positive way. If it's running to the ceiling, it's going to be make it more positive. So 2.1 is going to be 2.0, and then math.floor of negative 2.1 is going to be negative 3.0. So floor is going to be making more negative. As long as more negative, then it's going to be floor. And then the last one should be math.round. This one is your ordinary rounding. If it's greater than 4, then it's rounding up. If it's less than or equal to 4, then it's rounding down. Your ordinary rounding, basically. So now let's talk about casting. But before casting, I want to talk about characters first. So a character is a single character on the Unicode table. So you have a character A equals the character, so use single quote A. So this is going to be assigning them an ASCII table value A into my character variable A. However, as I said it before, each ASCII value is going to be corresponding to one of the integer value. So let me show you how this works. So if int integer A is equal to casting, I'm going to cast this. I'm going to cast my character into an integer, and then see how this looks. System out dot integer A. We print it out. It's going to be 97. Now let's go on to the ASCII table and see if it is. When you go on to our ASCII table, you will see that look for 97. It's going to be a small a. So casting is basically casting a data type to another data type. So you only want to use this if you're going to convert it from character to an integer or vice versa, or you can casting a double to an int or an int to a double. So double to an int, you're basically losing some of your data. Double int equal to 2.1. So if I want to cast this int double integer equal to, I want to cast this. So if I want to system out this, it's only going to give me 2, because what's after the decimal is going to be loose, because you're converting from a double to an int, which is not going to be very optimal. However, if you want to convert from an int to a double, sometimes you want to get a user input and only have to be double, and then otherwise your program will not work. It's better to cast it into a double and then starting work from there. So that will be the same thing. So too many variables. Int integer A equal to 1, and then double integer A equal to casting this to a double of an integer A. And then while I try to system out integra and then I want to print it out, it will go to be 1.0. So it's going to be adding a 0 to it, and it's going to convert it into a double. Now here's an interesting fact that I probably taught you in the first lesson or second lesson. When you have a character a equal to the character a, and then I have a character b equal to a plus 1. If I want to system out, no, not like this. So let me think of this. So a plus 1 is not going to work, but when you cast this to an int of a plus 1, this is going to work. So int b equal to casting of a plus 1. So casting of a is 97, as I showed you before, and then plus 1 will give me the ASCII table for my b. So my 98 is my b. So I store it into an int, and then if I want to character char b equal to casting my int into my character. So casting into a character of my integer b. So what this will output is going to be char. Let's print it out. It's going to be a little b, and when you're casting it, the integer back into my character, it's going to be according to which decimal it is and the corresponding character it is, and it's going to print out the character data type, not the int data type, because you're casting it to a character data type. So that's the basic idea of casting. You will use it more in the object-oriented programming, but for now, for the procedural programming, that's the basically you all need to know. And after that, so rounding and casting were done. Let's go on to substring and index of. So substring is pretty straightforward. So example equal to hello world. I'm using the same example for the last 10 lessons. Oh my god. I really need to get pretty creative with this. So example, that's my variable dot substring from beginning index to the end index. If I have a beginning index at 0, that's starting from the beginning. And then my last index, it can be 5. So going to 0, 0, 1, 2, 3, 4, 5 until the space. And then I want to system out this. Oops. Now let's print this out. It'll give me hello only because I have a example, that's my string, and I have a substring. So a substring will give you a beginning index and the ending index, and then whatever is inside there is going to be what you have for the your string variable dot substring. You can assign this to a new variable, and then you can have a part of a string to system out, but not everything. So that's pretty straightforward. So next you have the index of. Index of is a kind of interesting one. So index of a string character. So if I want to search for my O's, I can put a character O, not 0, and then I can system out this parentheses and then print it out. So it's going to be giving me 4. So it's only giving me the first O but not the second O. So in this case, you're going to search for the string, and then whatever it comes first, then that's the one they're going to display the index of. So that's pretty straightforward also. But when you go into SQL, like the databases, it's going to be very important to select a part of a data group, like a bunch of user groups, and you're going to search within the index of, and then search the keyword within that contains the letter O or something. That'll be very important for that. And then last but not least, we have the string conversion. So string conversion. So for example, I'm going to delete this and put 2.0. So this is a string. If I want to add something to it, it's going to be printed out as the 2.0 add whatever you have. So that's not going to work. Now I'll show you a way to turn the string into a double. So what you want to do is have a double, a string name, no, a double name. So call it string parsing equals to double, so this double is not the same as your data type double. This one is an object, and it definitely have messages in them. Dot parse double, and then a string, and then put your string in there. So example semicolon and system.out dot string parsing. It'll give me 2.0, and if I want to add to it, so string parsing plus 1 equals string parsing. It's going to give me 3, but not 2.0 plus 1. So that's what the string is gonna do. But when you parse it into a double, it's going to be treated as a double, and then add the algorithms that will be the same as a double, but not the same as a string. And then the integer will be the same. So integer dot parse int of my string example. So this one int. When you run this, not gonna work. Should be 2. And it's going to give me 2 plus 1 equal to 3, but not as 2, literally 2 plus 1. But instead, it's going to give me a result of 3. So that's it for this lesson. I'm going through some of the questions that I have not covered in the previous lessons, and thus consists of switches, trigonometry methods, exponents, rounding and casting, and character data type and corresponding checking methods, and substring and index of, and last but not least, I teach you how to convert from string into a int or a double with the parse methods. So I won't give you any homework for this lesson, but be prepared for a final exam. So I'm going to give you like 2 questions for you, and be sure to time yourself. It's the same as I did in my college. That's like 2 problems for approximately around like 2 hours. Yeah, one final exam is like 2 hours, 1 class period time. So be prepared and review lessons. Until then, stay active, be happy, and plan algorithms. I'll see you in the next one.